Today we're going to go into some definitions. First definition I'd like to hit you with is relation. What we mean by a relation, it's a set of ordered pairs. It's a set of ordered pairs. Well, we all know what ordered pairs are. Example, A. A is a relation. A is a set of ordered pairs. B is a relation. B is a set of ordered pairs. One more. C. C is a relation. These are all relations. They're spelled out for you. These are ordered pairs. D. Suppose I say D. Well, let D be y equal 3x plus 1. Is that a relation? Is that a relation? Kathy? You think no? Okay. Suppose x is 2, Kathy. What's y? If x is 2, what's y? 7. If x is 5, what's y?
16.
Are you getting a set of ordered pairs?
Yes.
You sure are. This is a set of ordered pairs. That's all that is. It's a set of ordered pairs. Set of x, y's. Likewise, E is a relation. F is a relation. And G is a relation. These are all sets of ordered pairs. H. Is H a relation? Yeah, it's a line. A line is made up of points. Each point is an ordered pair. This is a set of ordered pairs. It's a relation. Likewise, I is a relation. It's a set of ordered pairs. And J is a relation. These are all forms of relations. They are all sets of ordered pairs. Each and every one of these is a set of ordered pairs. Domain of a relation. Domain of a relation is the set of all first elements. Set of all first elements. What do I mean by first elements? The x values in this case. That are or could be used. The domain. It's a set of all x's that you could use or that you have used. That's all we mean by domain. What x's have we used? What x's can we use? Now the symbol for domain is D. So if I asked you to find D of A, D of A, the domain of the relation A, what would be the domain of the relation A? Tim? Go ahead. 2, 3, 1, 2, 3, 4. It's the set of all x's that we use here. So the domain of A would be the set 1, 2, 3, 4. Wong. Domain of B.
2, 4, 6, 8.
2, 4, 6, 8. That's it. Domain of C. Karen?
1, 2, 1, 3.
Okay.
1, 2, 3.
Right. We're not asking how many times you used a number. We just want to know what numbers you used. So it's 1, 2, 3. That's all the numbers we used for set C. Now these were easy. The domain was spelled out for you. Let's go down to the domain of D. Okay? We said this is a relation. Now the question is, what numbers can I use for x there? Any number. I can use all the reals. So the domain is all the reals. Now the symbol for all reals as you go on in math is the double bar R. This will be the symbol for real numbers. You see, I can plug in any value I want for x, and I'll come out with a value for y. Okay? The domain of E. What numbers can I plug in there for x there? Same thing. I can plug anything I please. I can plug in positive numbers, negative numbers, zeros, fractions, decimals, anything I want. So the domain of E is the set of reals. Domain of F. What can I plug in there for x in set F?
Square root of all real numbers.
Yeah, well, technically, right? But a little cleaner than that. A little cleaner. Numbers. Forget about square root. What numbers can I plug in there for x?
Perfect squares. Perfect square.
Oh, I can plug in 5. 5's not a perfect square. I can plug in 1, 2. All real numbers?
Not 0.
Not 0? Oh, I can plug in 0. X is equal to 0. Y would equal 0.
Square.
All positive. How about all non-negative? Okay? Almost the same. You see, I cannot plug a negative number in here for x because I have y squared equal to the negative number. Then what number squared will give you a negative number? No real number, the imaginaries, but we're dealing with, remember, this is an R cross R plane. Real and real. That's the only thing we're talking about. X has to be real, Y has to be real. So we're talking about real numbers. So the domain for F would be the reals greater than or equal to 0. I can plug in any non-negative number. The only thing I can't plug in here is a negative number. That means I can plug in 0 or a positive number. Domain of G. G is a relation. All relations have domains. Every single relation has a domain. What would be the domain of G? What can I plug in there for x? All real numbers? All real numbers? No. Can't have 0. What's wrong with 0? If I plug 0 in for x, I get 7 over negative 2. That's good.
Division by 0.
I can't have 2. Why can't I have 2? Right. One thing we cannot do is divide by 0. I told you, x can never take on a value that will make this denominator 0. So the domain here would be all reals except 2. Except 2. Okay? The domain are the values that we use for x or that we could use for x. All the values. Range of a relation. By the range of a relation, what we mean is the set of all second elements. By second elements, we mean the y's that we get by using the domain. All we mean by the range. When we plug in all the values we could use for x, what does y turn out to be? Now the symbol for range is R0. R sub 0. So if I want to find the range of A, what would the range of A be for this particular problem? Tim? 2, 4, 6, 2, 4, 6, 8. The range of set B would be what, Wong?
2.
2.
This 2.
Just 2. Right. That's it. That's the only thing we use for y. No matter what x was, y came out to be 2. Okay, let's skip down to D. The range of D. Now we said that we can plug in all real numbers for x. When we plug in all these real numbers for x, what is y turning out to be? All the real numbers, sure. So you see, both the domain and the range of set D are the set of reals. It's a set of reals. In other words, we use all the x's, all the y's. By the way, the graph of D was h. This is the graph. Remember, the intercept is 1, up 3 over 1. That's the graph of it. Notice the domain, where we're using all the values of x's. The range, well, it's going up and down forever and ever. We're using all the values of y. So the domain is the set of reals. The range is the set of reals. E. What would the range of E be? The domain was the set of all reals. When I plug in all these real numbers for x, what am I going to get for y?
All the numbers greater than 0.
Or?
Non-negative.
Right. Okay. You see, if we plug in all these values of x that we're allowed to use, all reals, what are we going to get for y? We're going to get all numbers that are not negative. In other words, if you square a number, you can never come out with a negative. So the range would be all the reals greater than or equal to 0. Now the hardest one on board. The range of f. The domain was the set of all non-negative numbers. In other words, I can plug in 1, 0, 2, a half, a square root of 3. I can plug in any number that's not negative. The question is now, what numbers does y turn out to be when I plug in these values for x? Think. Very good. Very good. All reals. You see, if x is 4, you get y squared equal 4, therefore y would equal plus 2, negative 2. If x was equal to 3, y would equal plus or minus the square root of 3, which is 1.724, whatever. But you can get all the real numbers. All the real numbers. Okay? So there we go. G, we'll talk about that in the future. Next course. The range. Okay, one more definition. Function. Without question, the most important word in all mathematics is that word right there. Every course after this course is the study of functions. That's why I say your math career doesn't start until you complete this course. The study of functions. If you go into the scientific area, the next course is called elementary functions. If you go into the business course, it's called analytic methods. But analytic methods is just the study of functions. You have the profit function, the loss function, the cost function, supply function, demand function, inventory function. They're all functions. It's all the math you have after this course is functions. Very important, very simple concept. A function is a relation. That means in order to have a function, you have to have a set of x and y's. You have to have a domain, you have to have a range. All functions have domain, have range. But it's a special kind of relation. It's a relation in which for each x, there exists one and only one value of y. Now, if you take the next course, if there's another course, they'll define it just a little bit different. They'll say for each element in the domain, there exists one and only one element in the range, which is what I said. For each value of x, but I've narrowed it down to x and y. Domain, you see our order pair can be anything as you go on in math. It could be P and V or R and T or whatever you want to call it. But the domain will always be the first elements. The range would be the second elements. But we're talking about x's and y's, so this is what we mean by a function. What this is saying, it says if I give you a value in the domain, any value in the domain, you can come back with one and only one value for y. One and only one value for y for each x in our domain. Knowing that, is a function? Is a function? Lynn?
Where you have a value for x and a given value for y.
Is it a function?
Yeah.
Yes. Lynn said yes. She had a 50-50 chance. You got it right, Lynn. Now notice, if I tell you that x is 2, everybody in the class says y is 4. You give me one answer, right? No matter what I give you for x. If I tell you x is 4, everybody in class says y is 8. One answer. For every single value in the domain, you only can give me one value for y. A is definitely a function. Lynn, is B a function?
Mm-hmm.
Yeah. She says yes. Again, she had a 50-50 chance. Again, she got it right. Notice if I tell you that x is 4, everyone says y is,
8.
if x is 4, b, b, b,
Oh, B.
b as in bugging, beautiful, same thing. Okay? If x is 4, what's y, Huang?
Is it? Oh, 2.
If x is 6, what's y, Huang?
2.
Yeah, no matter what I give you for x, you're only coming back with one value of y, it's a function. So b is a function. C, Lynn,
C is a function.
C is a function. Lynn says C is a function. Okay, Lynn? Talk to me, Lynn. C is 1. I mean, x is 1. What's y?
3.
I say 5. Who's right?
Oh, okay. Oh, no, I'm sorry. That's right. Okay, that is not a function.
Ah, it's not a function. Because you see, when I say x is 1, y could be 3 or it could be 5. But in order to be a function, there only can be one value. You have two values. You have more than one. So C is definitely not a function. Now, when your relation is in a set of ordered pair form, as A, B, and C are, how can you glance at it and determine if it's a function or not a function? How can you glance at these? Tony?
See whether there's any duplications in your first order
Right.
pair.
In order to be a function, all the x values must be different. Notice, A, they're all different. B, they're all different. C, they're not all different. C is not a function. Okay? We're down to D. Is D a function? Kathy,
There's only one value for x.
is D a function?
Yes.
Yes. Because if I tell you x is 7, y is
22.
one value. If x is 3, y is
7.
one value. No matter what value I throw out there for x, only one value comes back for y. Okay? So, D is a function. How about E? Is that a function? Sure. If x is 2, y is 4. If x is 0, y is 0. If x is negative 3, y is 9. One answer. No matter what I give you for x, you're only going to give me one value for y. Is f a function? I don't know. If x is 4, Lynn, what's y?
15.
No, y squared equal 4. What does y equal?
Oh, y squared equals 4.
Y, oh, yeah, y squared equal 4. What does y equal? Good question. Some number times itself is 4. What number times itself is 4?
2.
Or?
Negative 2.
Yeah, you come out with two answers. You see, when x is 4, y could be positive 2, it could be negative 2. Not a function. Only can have one value. If I give you an x, you only give me one value of y. G. G is a function. You see, if I give you a value of x, say I tell you x is 9, then everybody in class should say y is 1. No matter what value I give you for x that I'm allowed to use, it's in a domain, you only can come back with one value of y. If I tell you x is 0, y is negative 7 halves. Okay? Now when you have the rules, what you have to do is test it. Take a positive number, 0, negative number, see if you only can come out with one value of y each time. Now, let's take a look at these. H. Is H a function? Tony?
Yeah.
Yeah. I. Is I a function, Tony?
No.
No. J. Tony, is J a function?
Yes.
Okay. There's Tony's answer. Yes, no, yes. Tony got 1 out of 3. One of those is correct. Now, if you know which one's correct, you know which two are false.
H is correct.
H is correct, so these two are wrong, he says. And I agree. There it is. Yes, yes, no. By the way, H was the graph of D. Since D was a function, its graph is a function. I was the graph of E. This is the graph. X equals 0, y equals 0. X equal 1, y equal 1. X equal negative 1, y equal 1. X equal 2, y equal 4, negative 2, 4. This is a function. That is a function. J was the graph of F. F, you told me, was not a function. X was equal to 4, y was equal to plus 2, minus 2. Now, how can you take a look at a graph and determine if it's a function or not a function?
If it has positive values.
Yeah, I don't know what you mean by that.
It has to be.
It has to be one value for y for each value of x. Well, how do we determine that? Well, what we do is we take what's called the vertical line test. If you scan the graph with a vertical line and it never crosses the curve more than once, it's a function. If it crosses it more than once, it's not a function. You see, no matter where I draw a vertical line here, it will never cross. That means for each x, one y. No matter where I draw a vertical line here, it's never going to cross the curve more than once. This is a function. For each x, one y. Notice here, that's not a function. Okay? Now you said that D is a function. Y is equal to 3x plus 1 is a function. What does the value of this function depend upon? What does the value of this function depend upon?
X.
The value of x. So we say, hey, we have a function whose value depends upon x. And the way we symbolize it, we write it as f of x. We read this as f of x. And all we mean by f of x, the only thing we mean by that, it's another name for y. That's all it is. F of x and y are exactly the same numbers, the same animal. They're the same. Okay? So you see, instead of having y is equal to 3x plus 1, I can write that as f of x is equal to 3x plus 1. Now you recall, not too long ago, a few days ago, what we had to do was solve equations for y. Because as soon as we solve it for y, we have it in functional form. Remember our slope-intercept form of a line? We have y is equal to mx plus b, right? But another name for y is f of x. So what you're going to have in the future is this. You're going to have it in functional form. That's why I said this way is so important. Another name for slope-intercept form is functional form for a line. They are exactly the same. Y equal mx plus b, but y is another name for f of x. So we have f of x equal mx plus b. So in place of y, every place we have a y, we're going to replace it by f of x. And if we have it solved for y, we have it in functional form. Now, the first part of your alphabet, the A, B's, and C's, these are your constants. By that I mean ax plus by equals c. They're numbers, fixed numbers, fixed numbers. Okay? The latter part of your alphabet, the x, y's, w's, and z's, these are your variables. The middle part of the alphabet is dedicated to functions. Symbolisms we use for functions is f of x. We also use g of x, h of x, and m of x. These are the most common notations. They are all represent y. That's all they do is represent y. Okay? So let's go back to our given function. F of x is equal to 3x plus 1.